Hi everyone, today we're going to be looking at this geometry problem, and this one has a little bit more challenge. It's going to require probably some trigonometry, so if you don't know that right now, don't be alarmed if you have difficulty solving this. I'll go through and try to explain it as best as I can, and the problem goes as follows. The following diagram shows three mutually tangent unit circles. What is the area of the shape contained by the edges of the circles? And so that shape would be between these points where the shapes touch, everything within this section right here. So this is the area that we're looking for. If you want to try out this on your own, feel free to pause the video now and I'll get started in just a second. All right, let's get started. So the first thing to note is that these circles are mutually tangent. So they're not overlapping at any point. They're just touching at one point each, which is marked by the corners, I guess you could say, of the shape that we're looking for. We also know that these are unit circles, which means that they have radii of 1 unit. It's not any specific unit, it's not centimeters or inches, it's just imagine the number 1 as the radius. If it helps you to think of it in terms of centimeters or whatever your unit of choice, of course that's fine. But let's just mark the center of these circles and then look at the triangle that they form. And of course, these are all 1. So this triangle altogether has a side length of 2. Side length equals 2. Now, you might be asking, why did I create this triangle? Why did I point out the importance of this triangle? How does it relate to actually answering the problem? Well, let's zoom in a little bit on the triangle that we have and think about breaking it down into parts. So we have the triangle, and it's equal to three circle sectors. Oh, that looks horrible. 3 circle sectors. So this is sector 1, sector 2, sector 3, and then the shape that we're looking for is the 4th piece. So these 4 shapes combined together equal the area of the triangle that we're looking for. So let's just set up some variables to help think this through. So let's say T is the area of the triangle. Let's say S is the area of a circle sector. And let's say X is the area of the shape that we're looking for. So from this explanation I just gave, we know that the area of the triangle is equal to 3 times the area of a sector plus the area that's left over. So in order to find the area that we have, that we need to find to answer the problem, we know that we can just subtract 3s from both sides, and that'll give us t minus 3s. So this way, instead of directly finding the area of that shape in the middle, we can find the area of other pieces that are going to be a little bit easier to think about and find it indirectly that way. So let's start off by thinking about the value of t. T is the area of this triangle, this equilateral triangle, I might add, with side length of 2. Now imagine we took this triangle and we dropped a line from the top point down to the bottom such that it formed a right angle. Well, since this is an equilateral triangle, each of these halves of the base are going to be 1. We know that this hypotenuse is 2, so by applying the Pythagorean theorem, we get that 2 squared is equal to 1 squared plus the height squared, which gives us that 4 equals 1 plus height squared, which gives us that the height squared equals 3. Subtract 1 from both sides to get that, and then take the square root to get that the height is equal to the square root of 3. If you know about 30, 60, 90 triangles, you would also maybe be able to find this answer immediately. But you can also use it with the Pythagorean theorem, which is something that you probably learned earlier on. So the final step to find the area of the triangle is just to apply our area of a triangle rule. The area of a triangle is 1/2 times the base times the height. Our base is still 2. It's an equilateral triangle. And the height that we have is the square root of 3. These are going to cancel out, so we get that t is equal to the square root of 3. Now it's time to find the value for s, the sector of a circle. So the sector of a circle is given by the number of degrees of the sector. Let's just use the variable d. d over 360, where d is equal to the number of degrees of the sector. And this is multiplied by pi r squared, the area of the circle itself. And if you don't understand where that equation comes from, think about it this way. The number of degrees divided by 360 is like the fraction of the circle that the sector covers. So if it was half the circle, it would be 180 degrees over 360, which is half. And so that sector, which takes up half of the circle, would be half of the full area of the circle. So whether it's 1 degree, or 359 degrees, or 112.92789 degrees, taking that number of degrees, dividing it by 360, and multiplying it by the area of the circle is going to give you the area of that sector. So once again, we're going to apply that we know that this is an equilateral triangle, and as a result, all of the degrees of the angles of this triangle are 60 degrees. That's always the case for an equilateral triangle. So the area of this sector is going to be equal to 60 over 360 times pi times the radius squared. We know the radius is just 1, so this is going to be 60 over 360 times pi times 1 squared is just pi times 1, which is just pi. 60 divided by 360 can be simplified to 1/6. So we're finally going to get that the value of s is equal to pi over 6. Now the final step is just going to be to put it all together. So we know that our shape that we're looking for, the value of x, is equal to t minus 3 times the area of a sector. We got here that t is equal to the square root of 3, and that s is equal to pi over 6. This can be simplified. 3 distributed into this becomes 3 pi over 6. The 3 and the 6 can cancel out to 1/2. So this is just going to be pi over 2. And just like that, this is our final answer. I hope this explanation was helpful. Leave me a comment if you have any other questions, and have a great day.